everyone. I'm Shruti Singhal from Think Question Private Limited. Today I'm going to introduce you with the testing framework. We are going to understand what is testing and why testing is important. We are going to understand software development life cycle, the evolution of testing, testing life cycle, the difference between waterfall and agile model, what is manual testing, the advantages and disadvantages of it, and what is automation testing and the advantages and disadvantages of it. So now let us understand what is software testing and why it is required. Let us understand this particular thing with an example first. For example, there is a business analyst and it comes to a developer to create an application where he can post photos similar to Facebook. So the developer is going to create an application for it. Now, suppose he releases that particular application to the client. But when the client started posting photos, he observed then when the photos is of high volume, he could not post it. So that is a bug in the software. So we need to identify this bug before we release the software to the client. And that is why testing is really, really important. And furthermore, if the client wants to add some new feature, like for example, adding likes and comments to the photos, that only can be upgraded if my old features are not getting impacted by it. So that is called as regression testing. We are going to understand later. So that is why testers play a very crucial role during the software development lifecycle. So software testing is basically a process where we verify and validate the software application. So verification is while developing the software and validation is after development of software. So these are two different parts. So we basically verify the software and validate the software application, and we ensure that it is working correctly. But it should also meet the business and the technical requirement. If the software is working properly, but it is not meeting the intended requirements of the client, we do not say that the application is working properly. So the key objectives of software testing is that we need to identify the defects and the bugs. So this is a very, very crucial thing. So whenever we say that the application is bug-free, that is not really true. No application can be 100% bug-free. So the main area of testing is to identify those bugs as early as possible. We also verify the functionality that is meeting the requirements or not. So if there is suppose a button of order history, it should meet the requirement, show me the history of the orders. It should not be like it is just showing me the last two orders or last order that has been placed. It should be showing me the entire history. We also ensure that the software is having quality before the release. That basically means that it should be working smoothly and every functionality is working as required. So quality is very, very important. So if a customer is using the software, he should not face like that I am not able to understand the flow of this particular application. I'm not able to place an order. I'm not getting the required buttons as required, right? So there should be proper quality before the release of the software. So now, why again the question is why it is so important, why testing matters. So first thing is that we are able to identify the defects at a very early stage. So what does it mean basically? It basically means that if I catch any issue early, it is really cheap to basically debug it, right? And it is less risky also. For example, if there is a login bug or there is some forgot password bug, and if I'm catching that bug in the development phase, it will prevent any kind of customer complaints and then ensuring that trust is there still in the company, right? Because see, if this problem is going to come after I release the product, the customer will not have that much of trust with us, right? Then we also ensure the quality and reliability. This is a very, very important thing, that there should be the consistent performance. It should not be like that the software is behaving differently at some point and differently at other point. There should be a consistent performance. For example, the payment option, it should work the same way every time. Okay. Then we reduce the risk of failures. Obviously, if there is an unchecked software, and if there is any failure that might be reported later, we can have some data loss and financial loss too. For example, if there is a bug in any banking software that we are transferring some wrong amount, we have to reimburse that to the customer. So that is a very costly affair. So we have to ensure, right? Also, it improves the user experience because we are sitting at the place of customer and we are just checking the software at that point of time also. That is called as user interface testing, where we ensure that the app is working on all devices and it is very easy to navigate from one option to other. For example, if I have just registered to an application, I'm able to open the login page very easily. So there is a proper smooth navigation that is happening. Then supports maintainability. So if I have a well-tested code, I am easy to adapt to any change that I'm going to do later, right? So that is able, we are able to do with the help of regression testing. Then as we validate requirements. So we basically ensure that if I've promised that these all things will be there in my particular application, we are actually delivering the same. So that is very, very important. So basically a tester, if a tester wants, suppose there is some application and he could search any product by the name, right? So that is there. And if suppose if I misspelled certain name, that autocorrect feature should also be there. Because it is a common thing that can happen by a human that he's not writing the spellings correct for the product he's searching, that autocorrect suggestion should automatically appear, right? So again, it boosts the customer confidence because if you are giving a good product, the quality is there, then we are having good trust of the customers. A well-tested product is going to get obviously positive reviews and we will have repeated customers obviously. And last is compliance and security. So what is compliance and security is basically there are certain industries like healthcare, banking, where we have to follow some rules and regulations. We have to strictly adhere to them. So there came in the picture of security testing, right? So if there is any data breaches or if there is any legal issues, we should actually test them at that point itself so that they don't hamper the application later. So that is why, guys, testing is really, really important. So I hope now you understood why testing is so important. Now, before starting with the testing, we should also understand a very important life cycle, that is software development life cycle. What are the stages and why we are actually performing testing in between them. So testing is a part of software development life cycle. So development life cycle basically consists of various stages like planning and requirement analysis, defining the requirement, designing, development, testing, deployment and maintenance. So sometimes we even write deployment and maintenance as a separate stage. Now guys, first of all, let us understand what are the key aspects of SDLC. So basically it is a framework which help us to manage the entire software development process so that we can break down it into various phases. We have some well-defined activities, well-defined deliverables, which we are giving after each phase. And we have certain goals that has to be met after each phase. Because this is going to give us a high quality and reliable software within the budget and within the time frame that we want to complete it. So these SDLC models basically is a waterfall model wherein we are actually following a sequential approach. We complete one phase and then we move to the next phase and then to the next. Whereas if I talk about today's trends, we actually follow Agile, which is an iterative development where we are parallelly working on every phases. We are having customer feedback time to time, and that is there. But still, people are using both type of models depending upon the type of projects. But yes, Agile is in more trend, right? So we're going to discuss about this thing later. So as I have talked about the different stages, so let us just discuss about them. So the very first stage that we have is planning. So what actually we are doing in this planning phase is that we are defining what is the scope of the project, what is the objective, what is the requirements, what is the deliverables. So planning and requirement analysis is a very, very important thing because here we are actually taking the requirements from the customer. We are taking the inputs from the customer, from the sales, from the market, all kind of surveys we are doing in this particular phase. So here we are defining the scope of the project, what are the goals, and we plan out the resource, how much resource we want, how much time we want, what is the budget, and all these things are actually done. So here we basically utilize software requirement specification. So we actually create this document where we actually define what all things are required. right? Now, the stage two is defining the requirements. So here we basically segregate all requirements. So this is my functional requirement, this is my technical requirement, and we actually segregate them and then we get it approved that whether we can fulfill it or not. That is called as defining requirement. The next stage, guys, that we have is designing the architecture. So this is a very, very important phase again. So we basically have multiple designs for a product. For example, if I have to construct a home, I have so many designs in my mind, and I have to take into the picture that this is the time, this is the budget, and this is the resources that I have. So which model should I follow? So we design many product architecture based upon the design document definition that we have. And then this particular thing is basically given to the market analysis or to the stakeholders who actually have to buy that product. So here we do low level design and then we do actually the high level designing of that product. Okay. So the next is developing the product. So now this is the fundamental development of the product that is going to start here. Here we basically choose the language in which we want to create the product. It could be C, C++, Python, Java, etc. As per the software regulation, we have some code and standards. We have the version control. We review the code. All these things are done in this particular phase. After that, we have the product testing and integration. So here comes the software testing life cycle where we ensure that my software is working smoothly. We create testing, although minimal testing is conducted at small stage after every phase we are doing. But here we actually focus on all the types of flaws that are going to appear in my application. We fix them, we retest them, and then we ensure that the software that we are delivering does not have any kind of bugs. And here the documentation is going to play a very, very important part because we have a proper document where we ensure that things are working as it has to work. Then in this testing also, there could be two types of testings that could be performed like manual and automation depending upon what are you performing in that. We are going to discuss what is manual and automation in the due course. And then we have deployment and maintenance. Somewhere you might find these two phases written separately. That stage like 6 is deployment and 7 is maintenance, but that's okay. So here we are actually releasing a product. We are deploying the product in the real industrial environment. And then we are also taking some feedbacks and whatever maintenance is required, whatever version we create new versions after we maintain the things, we add new functionalities and that goes on during here. So in the deployment and maintenance, basically we release the planning, we deploy them, we maintain, and then we get the feedback. So this is all about software development life cycle, right? Okay. Now, guys, let us move ahead and understand the evolution of testing. Now, guys, this is a really, really important thing. You need to understand how basically testing came to the picture and how from one step to another we moved for basically identifying the software. Okay. So when I talk about the evolution of testing, so if I talk about long time before in 1950s and 70s, therein testing was not given that much of importance. The goal was just to develop the software and we need to just prove that yes, our software is working completely fine. So we don't have to focus on bugs. We don't have to focus on finding the bugs. So there is no formal testing team. So developers will themselves test the software from any ad hoc testing. For example, if they have created certain application, they will just randomly check whether login registration is working fine. They will not change the scenarios. They will not check in every situation they're working fine or not. So there is no structured approach for testing for finding the bugs until then, right? So that is why we used to miss a lot of bugs during that time. So that is why in 1970s to 80s, there was this realization that testing should come into the picture. So here came to the picture that we started introducing test plans, test cases. So herein we basically used manual testing approach. So the focus was shifted that yes, we have to check whether the software is meeting the customer requirement, whether it is meeting the specifications or not. We need to check that. So there were a lot of approaches that were used, for example, black box testing and white box testing. Black box is just testing the verifying the functionality, and white box is where we check in each and every code. So we are going to again go into the deeper part later on. So there were separate teams which used to perform different type of testings on the software. After that, there came a huge break in the system. The mindset of the team actually changed, and now testers were given a lot of importance because we realized that it is not just validating. We have to perform a lot more than that. We have to check the software, that if so many customers come together at a point at the software, then what is going to happen. So that comes as a part of stress testing, load testing, performance testing. So we have different more types of testing that came into picture, like functional testing, non-functional testing. So then there were different teams for performing the same. So testing basically became more risk based and negative testing. So basically we have to judgmentally pass negative data and check how my software is going to respond, which was not done before, right? And we have to do it that we will log in with so many customers in that application. We will see whether my application is getting crashed or not. So we will do it intentionally. And then came in 1990s the quality assurance era. So now testing was a completely structured process. We could have documents, we had proper plans, strategies, we have a proper teams, proper tools. So tools like QTP, it was developed by the company called as Mercury, that is Quick Testing Professional, that was there. Then load nurse, these basically tools came into the picture, and now they were actually a part of our software development life cycle. And also during this era, little bit automation started to begin. We realized that we need to do certain tasks automated. We have to do automate the certain tasks because it was very tiring to do the same task again and again for different test cases. So we realized the importance of automation over there. Okay. And then came, as you have heard about it in 2000 to 2010s, the guile and the continuous testing, wherein we were testing the things after every stage. So testing became iterative. We were giving it to the customers, we were giving it to the stakeholders, they gave us the feedbacks, and then we incorporated that feature and we did the testing again and again. So testing was done early, it was collaborative, and it was iterative. And agile methodology also came into the picture. And there was some automation tools that came into the picture like Selenium, JUnit, TestNG. They were very important part, right? So testing started at a early in the development phase, from starting from the requirement planning till the end of the time, testing was always there with us. And then you have heard about it, which is the current trend, that is DevOps and continuous integration and delivery. So herein we have the CI/CD pipelines. We integrate them during the build and the deployment, and we have some automated test cases which are running automatically. So what happens over here is, for example, you have incorporated certain code and you have just published that, or you have just posted that on the Git. For example, let us take an example of Git. So let's say you have done some changes in the code and then you have again deployed it. So what will happen, the test cases that you have written before for that code will run automatically to identify if there is any bug which is coming. So my scripts are going to run automatically. So this is kind of a regression testing. For example, you have added certain code, then also all my old test cases are going to run automatically. So even if you're sleeping at the night also, these things are happening automatically. So that is why this is continuous integration, continuous development that is happening in the performance and security testing of are also automated. And therein today you also know we have AI based testing tools like Testim, then we have Apply tools. This is the very current trend, that is automation testing with AI tools, which has already been is the current topic that everybody is interested in. So this is the future, as I have just told you, the AI for test case generation. These are self-healing. You don't have to write the test cases. They will automatically create the test cases based upon your previous test cases or previous analysis. They will do intelligent automation. So this is also a trend. It will reduce any kind of manual scripting that is required, and testing will become more autonomous. Basically, it is going to predict your future, from your previous test cases, basically. So suppose if you have written certain test case for the previous script or something, so it will automatically create some new test cases based upon that. So it is a codeless testing tools, and this is a highly gaining popularity. So this is all about the evolution of software testing, how basically it came and then grow and grow and grow. That is how it actually done. Now, guys, let us discuss about the next life cycle, which is really important, that is software testing cycle. So now let us discuss about this software testing life cycle, which is a very, very important part of testing. So here we basically define the phases that we need to follow while we are doing testing, which includes requirement analysis, test planning, test case development, test environment setup, test execution, and test closure. So now let us discuss about these phases in depth. So when I talk about requirement analysis, this is a very, very first step of software testing life cycle where we understand the requirement of what is to be tested. It might be possible, see, everything cannot be tested, right? So if there is anything missing which is not understandable, we will go to the stakeholders to understand their detailed knowledge about the requirement. We will review the software requirement documents, all the related documents. We will interview the stakeholder. We will gather all kind of information that we need. We will also understand if there is any ambiguity, if there is any incomplete requirement. So we will basically create a requirement traceability matrix. So in the requirement traceability matrix, we basically map the requirement to each test cases that we're going to create. So we will have a very clear understanding about the product. Next phase is, guys, test planning. This is a very, very important phase because here we are creating all the test cases and test scenarios. We calculate every type of effort and cost that is going to happen. Okay. We identify which all methods we are going to use. So this has to be manually tested and this has to be automated. So we identify all these things, all the environments that we need, which test cases can be executed, which cannot be, which are the functionalities which cannot be tested. So all these planning is done, right? We identify what are the deliverable. So basically we give a detailed plan of testing activities that will be performed in this particular phase. Now, the test case development is where the testing actually gets started. So here we identify the test case that we have developed and we will write proper test cases in a very clear and concise manner, which is very easy to understand. For example, if there is a login button, right? We will write down that if the username and password is correct, then login button should work, right? Login should happen. If my password is wrong, then it should have a prompt that my password is not correct, right? If suppose if I have left my username as blank, I've not entered anything, then a pop-up should appear that please enter the username or some error, justifiable error should be coming, not a single error like that. So we basically check whether the expected result is matching the actual result and we review and validate them. So this is also going to help to update our requirement traceability matrix. So where we actually verify that things are working properly or not. And here then we have the next step, that is test environment setup. This is an important part again. Here we actually set up the environment. So we basically talk about the hardware, the software, the network, the configuration that is all needed to run a specific test case. So once we have created the test case, then we will set up the environment for them, right? And then we are going to execute them. So after the test execution, what is going to happen? We have written that username, password, these are my test cases, and I'm going to run these test cases on this environment. Then we actually execute them. So when we execute the test case, then we basically perform certain things. So first of all, we actually match the requirements and if there is any defect, we log those defects. We share the result analysis. We perform the retesting if it is required. And if suppose a developer says that this is not a test, we properly document them by taking a screenshot and by telling this is the bug and this is what all has happened. So this is properly prepared at this step. And lastly is the test closure, where all the test related activities are documented, they are properly completed, and we basically keep it for the clear understanding for the software quality and reliability. So this is the final stage where all the things are properly documented, which includes the test summary report, the defect tracking report, what environment in which we have done the test cases, what knowledge we want to give, any feedbacks, anything, improvements that has to be required is all kept in this particular type. So this is about software testing life cycle. Okay. Now, guys, let us move as I have just discussed about this terminology that is agile testing. So, let us understand what is this agile testing and why basically it came into the picture. So, basically, guys, see, when I talk about this thing, there were a lot of methodologies that were used before, or we can say models that were used before. Like there was a waterfall model, there was V-type model also, there was spiral model, which was for risk management. But if I talk about the today's infrastructure, then in today's we are basically using agile model a lot. So what is this agile model? Agile model is basically an iterative model wherein we are giving the deliverables after every small duration. Okay. So let us understand. So what is happening in this agile model? So in this agile model, basically what is happening is we are testing an approach. This is an approach where testing is ongoing. It is not a separate phase. After every requirement analysis, like say we are doing, then we are doing designing. After everything, we are performing the testing. So it is done concurrently, simultaneously with the development. Right. So developer, business people, they are working all collaboratively. It's not like that one phase is completed, then we are going to the next phase and then we are moving to the next phase. Not like that. So that is why it helps us to give us a continuous feedback, right? Suppose if there is some requirement and we have moved to the design phase, and the design phase we realize that there is some bug, it is not working according to us, then we just give the feedback and accordingly the design is changed, right? So that is why it supports an iterative and incremental delivery. For example, if the client has asked us to create a functionality, but later on he realizes, no, this is not what I actually wanted. Maybe the way we understood the things might be different. So that is going to give us a good quality software also, and it will also ensure to create a good trust with the stakeholders, right? So let us understand what is the difference between waterfall and agile model. So basically, waterfall model is a sequential development process where one phase is completed, we are moving to the next phase. We are not coming back to that phase again. Whereas in agile, it is an iterative development process. So we are repeating the phases again and again, depending upon whatever feedback we're giving. So in waterfall, we have to do a lot of documentation because we have to say that yes, this phase is completed, so this is being delivered. We prepare the requirement traceability matrix, business requirement specification, and all. Whereas in agile, we are just emphasizing that the software should be working as per the needs of the customer. And it is very difficult to incorporate any kind of changes once we have made in the waterfall model because once the phase is over, it is not ready to adapt to any kind of change. Whereas in agile, we can make changes, right? And in waterfall, testing is done after the development, whereas in agile, it is throughout the development process. After every phase, we are doing testing. So in waterfall, we have to think about whatever planning, design, everything before, whereas here the planning and design can also be done increment. So waterfall model is basically suited for the projects which has fixed requirements, whose requirements are not keep on changing, right? For the small projects. Whereas if we have evolving requirements, changing requirements, we should follow agile model, right? So again, waterfall model is a top-down approach, right? Whereas agile model is a collaborative approach. We all the developer, testers, and everybody collaborate and work together. Here we have the developer, then we have the tester, then we have the client, and that's how it is going on. So customer feedback is very limited. And here we encourage that the customer should give us feedback, and accordingly we can incorporate in that process. So in waterfall model, the goal is what? We have to just deliver a fully functional product at the end of the project. Whereas when I talk about agile, here we have to give a minimum viable product. Means a customer is also satisfied. We are also talking about the time, budget, and we can also iterate and improve upon it any point of time. So that is the goal. So I hope you understand the traditional and today's approach and what is the difference between the two. Now, guys, now, let us talk about this trend that is DevOps, which is continuous integration, continuous development, and how basically it is working in today's trend. So, this is also used a lot for the testing. So, this basically again uses agile methodology. So, what we have is in this, we have agile development. So, for example, we have basically it follows the functionality of sprint and scrum. So, what is a scrum? Scrum is basically a framework. in which we developed a model where we generate tickets and we assign the task that has to be completed. And sprint is a small meeting, or we can say a time box framework, where we are delivering certain part of the product. So that is how it basically works. So agile, what happens in it is we are having some product stage. We have the backlogs. Whatever backlogs are the tasks that we need to accomplish. And a sprint generally lasts for 1 to 2 weeks, and then we give the product. So here we have the daily stand-up meetings where we discuss what are the things. And then we have the continuous integration. So whatever code we are going to develop, we are going to commit them into the code repository using some Git. And here we have the continuous integration server where we are having the build and the unit code and the code quality, or checking the code quality using the code quality metrics. Now comes the important picture that when you are integrating your old code with the new code, there is one thing that goes in the process along this continuous testing. So in the testing, we collaborate with the testers, with the stakeholders, and we write down the test scripts and we create certain tickets, right? So any kind of issues, we are going to track them. And there are so many teams involved: quality assurance, user acceptance teams, and all. And here we basically track any kind of issues by following the metrics. So once we are doing continuous testing, we are also going to get a continuous feedback from the customer. So whatever feedback is we are going to get from the infrastructure as a code, then accordingly we are going to incorporate them. And then again, there will be a new sprint from that feedback. Then again, that code will be incorporated. Then testing will be done. Again, it will be delivered. And then this is whole life cycle is going to go in sprints. So that is why this is a very, very good approach, because we are giving the customers as the product which is required by him. It is a fully means they are ready to accept that product. See, because what happens is sometimes we are giving the product, but the client later on says that this was not our requirement, you didn't understood it properly, we mentioned this, you understood this. So here we are giving them small deliverables to make them understand that yes, this is the true picture that you wanted in your product, and we have delivered this to you. So that is how we are giving a fully satisfied product to the customer or the stakeholders. Now, guys, let us move towards the next topic, that is, what is the difference between manual and automation and what are the stages involved? So, guys, we have two types of testing. The first one is manual testing, and the second one is automation testing. And inside them, we have functional, non functional. We are going to cover it later. So, manual testing is where we basically involve human testers. So, they are going to write the test cases without the help of any automation tool. So that is how they will actually interact with the application. Here, there is a direct interaction with the application that is going to take place. We need to understand this thing. Okay, so this direct interaction with the application, which is going to upgrade our software, because they are actually realizing how the software is intended to work, right? Okay. So when I talk about manual testing, what comes into the picture is that basically there are certain things which cannot be automated. There are many things basically which cannot be automated. So in manual testing, we basically take those things into high consideration. For example, if I want to check anything is working according to our need or not. So basically, we are performing a step-by-step approach here by identifying what things has to be tested. For example, if I talk about some color scheme, okay. So if suppose there is something written with the white and then we have a gray text over here, it will not be visible. So this thing cannot be automated, right? So this involves manual testing. So we have a direct interaction with the application, and this basically relies on the tester knowledge, his experience, his intuition, what he's thinking about that application. So it is completely document driven. You have to write down all the plans, all the cases, and then deliver that document. So all the same steps that we had in software testing life cycles are being followed over here. We plan the test, then we have the test cases ready with us. We have the environment in which we manage the hardware, software, network configuration, whatever things we need. Then we execute them, and then we report and analyze, do the reporting and analyze those test cases. And lastly, we're going to close those test cases. So what is the advantages? The very first advantage of manual testing is it is cost effective. Now, what is the meaning of cost effective? So because so when I talk about, see, whenever we are having any kind of test cases, there is no need of expensive tools when we are doing it manually. right? So when there is a short-term testing or one-time testing, in that situation, we can do manual testing. So manual testing, for example, if we have a small project, we just have to test it one time, right? Or there is some complex user interactions, then we do it. And sometimes we have some exploratory testing, wherein we are discovering any unexpected thing that might happen, right? We do not know that these are going to happen. We are just thinking and we are just testing it out. Or we are just testing the user experience. We are evaluating the how the user is going to experience if this thing is going to be changed. And if there is any quick check without any formal test cases, that is called as ad hoc testing. There also manual testing is highly important. And as I just told you, like if I have to detect any kind of visual or user interfaces, then also manual testing plays a picture. So it is best for startups and low budget projects. So as I have just told you about that, it is better for exploratory, ad hoc, and usability testing where you can explore the application freely, catch any kind of unexpected issues that is going to come. Because human can think and feel, na? Automation cannot think and feel. Next is flexibility and adaptability. So it is easy to adapt to any kind of frequent changes that are coming, right? We can quickly update the test cases based upon the changing needs that are coming. And we can also detect any kind of visual and GUI. For example, if I talk about captcha code, that cannot be automated, right? You have to, captcha means that you cannot automate. It should not be robot who is going to do that. So that can be done. And then if I have to check any kind of alignment, any kind of consistency layout in the layout and all, that cannot be automated. Next is it is easy to learn and start. You do not need any programming skills. Obviously, if I'm doing automation, you need programming skills for that. You should be either knowing Java or some other programming language. Whereas in manual testing, we do not need to know any kind of language, right? And you basically mimics user action. So whatever manual testers, the way basically behave, how the customers are going to behave. They identify your real world bugs. So that is why it is best suited for any kind of complex interaction, and you immediately give the feedback. You try different test paths, you have faster response, and there is no environment and tool dependency. You can do it with just an Excel and the application. You don't need any kind of proper setup over there, right? So these are the advantages of manual testing. Now, everything which has advantages, comes with some disadvantages. So let us now talk about the limitations of manual testing. So as I have just said that it is little time consuming because obviously it will take more time to execute the test cases. For example, if there is a large application, you have to text 100 cases for login button. So tiring it will be now to run those test cases to find whether it is run for this particular combination of user password or not. So in that situation, automation actually works. And obviously regression testing in which we have to verify again the old test cases are working good or not when we have done certain updation, then that is also very tedious task, right? Because the slower the test cycles will be, the release will keep on getting delayed. Then it is not suitable for repetitive tasks. As I told you, it is monotonous and more repetition will do human are prone to errors, right? Because human might miss certain steps, might misinterpret certain requirement, or if we forgot that yes, we got a bug and we forgot to log it. So that is because human are not machines, errors can happen. Then it cannot be scaled. Suppose I have written 100 test cases initially, then I have written 1,000 test cases. So it cannot deal with it. Then there is no support for performance and load testing. For example, we cannot simulate if thousands users come into the picture to perform or to use that application. We do not know how it is going to perform in that situation, right? It is not going to tell us, right? And if there is any network problem, all these things cannot be done. So we need the automation tools over there. Then it has a limited coverage when it comes to time constraints. It has a very limited coverage. And obviously, we have to document each and everything that is going in this particular test. So that is why guys came into the picture that is called as automation testing. Because here we have to do every detailed documentation of every data, every steps, every bug that is coming. So we have to document them. So that is why guys came into the automation testing. Now, what is automation testing? So automation testing, we have just discussed about it a little bit in the entire session, but it is basically using specialized tool to control the execution, where we are comparing the actual result with the expected result by writing certain scripts which will run automatically. So we are extending the human capabilities. Obviously, the scripts will be written by human, right? It is not automatic scripts that are coming. But yes, with the AI, the scripts will be also automated. But right now, if I talk about, we are writing those scripts. So what is happening over here is, so first of all, we have to determine the scope. All test cases cannot be automated. So you have to determine the scope of the test automation, and then you have to select the right tool. For example, if you're doing performance testing, you will use JMeter, right? If you're doing normal interface, the verification of some buttons or interface testing, right? Then you will use Selenium, maybe. And then you have to write the plans, the design, the strategy. Again, you have to set up the environment, and you have to go for the test reports generation, and then you have to execute those again and again. So this is how automation testing also takes place. Now guys, let us understand the advantages and disadvantages of automation testing. So as I told you, generally if I talk about automation, then obviously it is high speed, it is more reliable, it is reusable, right? And you can run the test case again and again. And obviously, if you're sleeping, also the test case was going to run automatically, and it is cost effective. And as I just told you in DevOps also, it has integration of CI/CD. But yes, so these are all the advantages: the speed, the reliability, reusability, parallel execution. We are parallelly executing a lot of test cases. We can also do cross browser testing. We can run the same test cases on Chrome also, Firefox also. So it will not consume a lot of time, right? So this is the advantages of automation testing. And then we come to the disadvantages. So everything has a disadvantages. There are many test cases which cannot be automated. So the first thing is we have a very high initial cost because we need to hire somebody who knows the programming skills, and we need to invest on the automation tools, right? And we need skilled automation and engineers for writing those scripts. Then we cannot perform UI testing or usability testing. Basically, we cannot judge the user experience. Now, automation is going to do automatically certain things. We cannot judge any kind of user experience over here, any kind of layout problem, alignment problem. We can't actually check using the automation, right? And so only human eye can check certain things. And there is an overhead, obviously. If there is some change in the UI, then you have to do the update, right? And obviously, as I just told you, that there are some predefined steps and validations that you need to follow. You cannot explore, you cannot do creative thinking over here, right? And sometimes you might miss some business logic or some context level thing, right? So everything that looks good might not be look good, right? Maybe it is not that smooth. And as I told you, not all tests cannot be automated, like captcha code, barcode scanning. We can't automate that. That is actually has to be done by the humans, right? For example, whether you're receiving the OTP, when you say that we'll get an OTP for logging in or for registration, that cannot be automated again, right? Then steep learning curve means you obviously need to learn Java, Python, Selenium, TestNG, all the tools and everything. And it also depends upon the environment in which you are going to test. It may fail because of unstable environment, not because of the unstable code, improper data, or some tool specific issues that might appear may lead to flakiness or unreliable results. So let us quickly discuss about the difference between manual and automation. Then obviously, as I said, that manual testing is slower, whereas automation has a faster execution. The initial cost is very low because we can hire somebody who has a basic knowledge about the application, wherein the tester should know the programming skills and frameworks, how to use those frameworks. Then obviously manual testing, if I talk about the long-term costing, it is higher, and long-term cost is low in automation. And in manual, we need human intervention at every time, wherein here humans will write the script once and then automatically it will run. So minimal intervention later once the setup is done. Manual testing is more prone to human errors because human might make mistakes and they make mistakes, whereas automation is consistent result. Manual testing is highly adaptable. We can adapt them with the new environments, new software, new platforms, whereas automation is less adaptable. Manual is again limited by resources, whereas automation has a lot of coverage which we cannot cover by the manual testing. And if I have to perform exploratory, where I have to explore with my creative thinking skills, I will use manual than automation. And as I told you, regression testing means testing the old features when some new feature is done. Then regression testing is very time consuming in manual, whereas efficient in automation. And when I talk about visual validation, that is my user interface testing, how the things are appearing to me, that is strong in manual and limited with automation. And technical skills, as I've just discussed, manual does not require any such technical skills, whereas in automation, we need programming knowledge properly. So this is about manual and automation testing. So I hope you got an idea about what is testing, why it is important, what is the difference between manual and automation testing, and how basically evolution of testing came into the picture. And we have also discussed about the life cycle, that is software development life cycle and software testing life cycle. So in the further, we are going to discuss about the various types of testing. Thank you, everyone.